So following on from the previous video, we looked at y equals x squared here times sine of x here, and it turns out to look something like this. You would start out with your sine of x, and then your x squared will look something like this. So this point here gets moved to here. This point here gets moved to here. This point here gets moved to up here. And then on the negative side, it gets moved to somewhere, well, the equivalent of this here, but then it gets flipped over. So it's this distance here. And then this point here is -1. So it's this distance here being flipped. So it's around here. And then looking at this here, this point here is -1. So it's this distance here being flipped over. So it's somewhere down here. So you're on the positive side, it will look something like this. It will look something like this. Hang on. It will look something like this. Okay. Well, something like this, and it gets bigger and bigger. When you try and plot it, it will look like this. Okay. So believe it or not, that this here is your y equals x squared here. Okay. So you start out with your sine of x going along here. And then this point gets dragged up here. This point here gets dragged up here. This here gets dragged down here. This point here gets dragged down here, and so on, giving you a graph looking like this. And the reason why these numbers are so big is because if you look at this bit here, sine of x, well, your sine of x will look something like this, 360. So this point here is 360. Now this is your x value at this point here. So you got to, don't forget, so x here is 360. You've got to put it into here as well. And then, well, this when you come to square it, you see 360 squared just for this point here, it would be a massive number. That's why these numbers are so big. It's because of this x squared here. It magnifies the degrees by a lot. Because think about it, and another period would be 720. So when you put 720 into this x squared here, it will give you 720 squared, making this a really big number. That's why these numbers are so big. Okay, you could tidy up the graph by changing the period. So for example, with this one here, your normal sine of graph will look like this. So your normal sine of x will look like this, 360. But don't forget, you can always manipulate it so that you can have a period of 4. So this here is 4. So when you come, so this is your x value at 4. So when you come to put 4 squared into here, it's a nice small number, 16. My point is that you can always change a period. Remember, changing the period to 4 is basically sine 360 over 4 and then x here. This is your if you plot y equals this here, it will give you this graph here. If you don't understand this bit here, watch some of the earlier videos. Well, anyway, sine. So this red line here is y equals x squared sine blah blah blah, and this bit here is your y equals x squared here. This is your y equals x squared. In the previous video, we looked at the positive side. Okay. Now we're going to look at the negative side. See what happens when we try and plot. When we try and plot. Hang on. When we try and plot y equals x squared sine of x, but on the negative side. So well, in the previous video we looked at the positive side. Now we're going to look at the negative side. Okay, so start out with y equals x squared sine of x. Okay, so you start out with your graph. Hang on. So sine of x here would be 360 here, and then this here, oops, this here would be one period, and then this here would be another period, and this here would be another period, and then this here, well, and so on. You start out with your sine of x graph. Now looking at your y equals x squared here, it will look something like this. Hang on. Oops. well, it's gonna be a quadratic like this. Hang on, I'll try and make it steeper. Well, anyway, so roughly speaking, it's like this. Now, looking at this point here, this is negative 90. Don't forget, because from one period is 360, so this bit here is 180. So from here to here, it's 180, negative 180. So this here must be negative 90. Well, at negative 90, so don't forget, this is your x value. X equals negative 90. Well, when you put negative 90 into here, this block here becomes negative 1. Okay, and then negative 90, put it into here, it would become positive 90 squared. Just imagine this 90 squared to be a big number. Okay, so now ignore the negative for the time being. Just do 1 times 90 squared. That would take you from here, and I know you can't see it, but it would take you to here. But because there's a negative here, you have to flip it in the negative direction. So well, hang on. Let me just illustrate it with one period, because hang on. So let me just illustrate it one period. So your sine of x looks like this. Sine of x here. This is your 360. Okay, 360 here. This is your negative 360. Now your y equals x squared will look like this. Hang on. Okay, it will look something like this. Now this here is negative 90, from like earlier. Negative 90. So we are trying to look at this here. Y equals x squared sine of x. Now when you put negative, remember x here is negative 90. When you put negative 90 into this block here will become negative 1. When you put negative 90 into this block here, it becomes 90 squared. Positive 90 squared, don't forget. 90 squared. Yeah, when you square it, the negative sign goes. That's why you got 90 squared. Now you've got to get these two, multiply them together. So just ignore the minus for the time being. Just do 1 times 90 squared, and that would take you from here to this point here. Okay. Now taking into account that earlier negative, so taking the negative into account now, it will flip this thing upside down here. So it will take you to somewhere here. So this graph here will look like this. Well, it will look like this. Hang on. Well, and then looking at this point here. This point here is 270, negative 270. Well, if you put negative 270 into here, that would be a positive 1, and you can see it's a positive 1 here. And then negative 270, put it into there, would be 270 squared, which is a big number. Just know that is a big number. So really, this point here gets dragged up to this really big number here. This here will be 270 squared, whatever that big number is. So this point here will be 0. Okay, because if you put negative 180 into here, negative 180 into here, then this whole block here will be 0. And then this, well, anything times 0, the whole thing will be 0. So this point will be here. This one here will be at 0. So looking at on the negative side, it will look like this. It will look something like this. Okay, and then you can use the same argument to extend this. So normally your sine of x will look something like this, and then this point here will get dragged all the way down here. Okay, the 0 will stay the same here. So this point here gets dragged all the way down to here. This 0 here will stay still. This point here will get dragged. This point here will get dragged all the way up here. Let's say all the way up here. Okay, and then this point here will be 0. This point here will remain at that point because it's 0. So if you were to extend this here, so on the negative side, it will look something like this. All the way down here, and then back to the 0, and then this all the way up here. Okay, wait there, all the way up here, and then down to here. You see, it will look something like this. So your graph will look something like this. Hang on, just on the negative side, it will look something like this, all the way up here, and then down here. Okay, well that just gives you an idea of what's going on. Okay.